So thank you very much for inviting me to speak again. Having spoke on Autonomous Data Warehouse Cloud last time, this time I want to talk about my favorite subject, which is SQL Pattern Matching. And this is a presentation that I've done before, and it's to do with a specific use case for SQL Pattern Matching. I'm not sure how many people, normally if I'm in a room of people, the first thing I'll ask is how many people are on 12C, but that's a bit difficult to do in a webcast. So you need to be on database 12C for this. Hopefully you all have that. And this is a feature that we've added called Match Recognize. You may have seen it, you may have seen or heard me talking about this in the past. My name is Keith Laker. I am part of the Data Warehouse Product Management team. I look after Analytics SQL. You can see my Twitter feed handle in the bottom there. And it's a fairly straightforward presentation today. I'm not sure how long we've got. Normally this runs for about 45 minutes, an hour. Oh, you are sharing the PowerPoint page. Ah, yes, good point. Let's flick into presentation mode. That might be easier for everyone, and you'll get to see the whole page. Okay. So what I'd like to cover today, first of all, is like a quick introduction to Match Recognize. It tends to be, when I present to people, quite new, this concept and the fact that we have this feature actually inside the database. Then I'm going to sort of jump into a use case around how would you find fraud using Match Recognize. And we'll look at some different scenarios. And sort of the key point here is, and we'll see this in the first part, is there's lots of ways of doing this today. And what we're trying to do by bringing this back inside the database is to simplify your code. And most importantly, this sort of comes out with point 3, where we get into, okay, what happens when your business requirements change? Which is quite often the case, you know, particularly with things like pattern matching. Once you find the pattern, you then sort of want to add more nuances. And then the question becomes, well, how do you do that easily? And how do you not break what you've already done? And then, having looked at, you know, the power of SQL for doing that, just pattern matching, we come to this last part, which is, okay, the big advantage of SQL, the big advantage of you putting this back in the database is now you've got access to lots of other types of analytics that you can join up. What I call analytic mashups, where you can take different types of functionality, bring them all together and create something very exciting. So, okay, let's have a look at some straightforward stuff. If you're doing pattern matching today, the chances are you're probably not doing it in the database. You're probably pushing data out, or data before it arrives into the database has pattern matching applied to it. And there are lots and lots of different languages that you can use for doing this. Perl is a good example. It's not listed on here, but many people will use the programming language Perl to do various types of pattern matching. But there's all sorts of processing that you can do. Now, they all natively support pattern matching, but what we've actually done is part of ANSI 2016, there was an addition to the SQL code, which allows you to do row-level group processing. Now, we already had regular expressions. Most of you are probably aware of those. We had those in the database, but they're sort of row-level processing and tied to a specific column that you're working on. What you want to do with pattern matching is not necessarily work on a specific row and a specific column within that row, but you want to be able to move within a sequence of events and be able to step backwards, step forwards, step across to different columns, do different types of analytics, So you have this sort of inter-row processing going on. And that's what we've added. And that's what's part of the ANSI 2016 standard. So you have a new construct inside the database now, and it's called match recognize. Importantly, it is part of the ANSI standard. So if you are concerned about sort of the lock-in of using non-standard SQL functionality, this is part of ANSI. So it's not a unique Oracle capability that if you started to use, you'd be stepping outside of normal standard processing. It is part of ANSI 2016, and that's what we've implemented, along with some other features that are part of the ANSI standard that we're also going to look at as part of this processing. So when you come to use match recognize, how do you go about doing it? If you've used window functions, the analytic window functions, where you can do time series analytics such as cumulative totals within a window, moving, preceding, following rows to get moving averages and those types of things, where you've got concepts such as partitioning, grouping, order bys. Those concepts that you have there are the same basic concepts that we start with as the foundation for match recognize, and then add new capabilities on top of that. So the basic way of thinking about this, or the basic way that I think about it, is there's a 4-step process here. The first thing you have to do is to logically partition and order your data so that you can make the pattern visible or available for processing to match recognize. Then step 2 is you tell us what the pattern is that you are looking for. And you do that through 2 essential features. We use regular expressions, and if you're used to other programming languages, you've used it already in database regular expressions, you'll understand what this is when we get to it. And then you describe in Boolean terms how those patterns, what they look like, how they're defined. And then we look at applying that matching process to the sequence of rows. And within that, we can, as we go through and discover the pattern, return different levels of data to you. So different types of rows and different levels of aggregation within that pattern. And you'll see that as we go through this example. So we're going to do a business case now, and it's based on a very simple set of data, and it's looking for fraud within a data stream. Now, what I've done is I've taken this concept and put it into Live SQL. So hopefully everybody knows about Live SQL now. If you haven't, let me just here. If you haven't seen Live SQL already, and if you've not used Database 18c and you'd like to know about some of the features that we put into Database 18c, hopefully you can see right down at the bottom here, Live SQL's running 18c, 18.1 database. So if there's any features maybe that other product managers have been talking about relating to SQL, PL SQL, etc., that you'd like to know about, that you'd like to try out, you can do that through Live SQL. And part of that is I've created some tutorials. There's a whole series of them here, but this one is specifically related to this particular topic. So it's a fraud demo that I built for the Oracle Code events. And you can see here, so there's an overview section. Let me just open this up a bit more. We can see it. So we have an overview section. We'll do some setup. We'll add some data, and we're going to come back to this in a minute. But you'll get the idea. So all of the information that I'm going to share with you today is going to be in PowerPoint, and also it's going to be available through Live SQL. So you can actually run this demo. You can see all the code that goes into it. If you're completely new to pattern matching, then I've shared the link in the chat window for you, so you can get hold of this. I've put together an ebook, which will, at the moment I'm volume 1, I'm still writing volume 2. It will give you a complete introduction to using SQL pattern matching, and it's available in iBook format. If you want, you can then step through, there's a whole series of use cases, and then we get into the syntax. So if you've got a Mac, an iPad, probably not an iPhone, might not work too well on an iPhone, but you can download this iBook called Complete Guide to SQL Pattern Matching. Most people, I guess, probably don't have a Mac, so you can pick this up in PDF format as well, and it'll take you through everything. It's got links to each chapter has its own Live SQL session, so you can then go over to Live SQL and try out the statements that you've used. So that will get you in. That'll explain everything to you. And what I'm going to do here is go through a specific use case. So what we want to do, here's the business problem. We've got a data set and we want to find suspicious money transfers. How do we define a suspicious money transfer within an account? Okay, what we're going to look for is I want 3 or more small money transfers. Let's say that's less than $2,000. Those 3 transfers must occur within a 30-day window. Once I've found those 3 transfers, I'm then looking for a very large, let's say more than $1 million, within 10 days of the last small transfer. So that's what I want. That's how I'm going to define a transfer that is suspicious. That's the pattern I'm looking for. When I found that, what I want to know is, okay, who's the account? What was the date of the first small transfer? What was the date of the last large transfer? And the amount of that large transfer. So how are we going to do this? Okay, first thing we need is a data set. And if we were looking at a real world scenario here, we'd probably end up with something like this, a data stream that looks key value pairs. So if we were going to work with this data set, what we probably would have had to do in the past is take this and transfer it into a more user-friendly, i.e. database-friendly format that we could then load through some sort of data integration utility. With 12c, we added the ability to process data in JSON format directly. So if you've not come across this, we can actually do JSON data processing directly in the database. What it allows us to do, excuse me, just a quick drink, is take the key value relationship on the left and convert that very simply to a relational table structure. And you'll see this in this example on Live SQL. We'll show you the code of how to take the file, store it directly as a JSON object, and then query it using SQL as a normal relational table structure. And it's a very straightforward process. So if you haven't seen this in 12c, you can hotkey over to Live SQL, and you'll see part of the setup here is to create I insert that into my editor. I will create a table and I'll call it JSON transactions. It's a club, and I'm going to add a constraint to say that it's a JSON, it is valid JSON. So it's a transaction, doc is my column, and it's JSON, and that's the constraint that I'll enable. And then, having done that, I can go in and add some data to it. So if I quickly do that, let's just quickly run that. So there's my table created. I think I can insert all of that. There's my state. Now, how do I query a JSON table? So now to query it, we just point to the JSON document and then the key, in actual fact, the key to our data set. And then I can give it a column alias. So if I run that, you'll see my JSON document is now in column format, row column format, rather than key value pairs. And the rest of this will sort of give you more insight into how you can do this. So the live SQL will step you through it. Very, very straightforward process. Pick up the key value pairs, convert them into a table structure. Now, obviously, in this example, we're actually storing this inside the database. There's no reason to actually load the data, sort of insert it into a table. This could be an external table over a file, say if we were in the cloud in an object store, whether it's Oracle Object Store, Amazon S3, Microsoft Azure's Object Store, we could create an external table over that. Or if it's an on-premise system, we would just create an external table over a directory object, and then you could query it without having to preload it into your database. But obviously for live SQL, I've set this up as a table inside the database and loaded values into it. So just be aware of that. There's actually no need to load the data at this point. Okay, so what are we looking for? Here's our 3 small transfers. So I've got a deposit, I've got a transfer, I've got a withdrawal, transfer. So we can see straight away I've got 3 transfers and they're all happening within a 30-day window. Then what I'm looking for is this large transfer here. So that has got to occur within 10 days of this transfer, and we can see it does. So that's 7 days. So there's our 3 small transfers. There's our large transfer. That's what we need to look for. That's the pattern that I'm expecting to find. Those are the pieces of data I'm expecting Match Recognize to pull out for me and highlight as a suspicious transfer. So how do we do this? Match Recognize, if you do a select statement, you'll see underneath the from clause, we add this new keyword, Match Recognize. The from clause acts as the input into Match Recognize. So in this case, I'm going to select and I'm going to take some columns from my JSON transactions data set, and I'm just going to feed in events where the type is transfer. So notice here, normally you would apply some filtering. You do select from, give it the table name, and then the where clause would come at the end, and that would filter the rows for you. You sort of do this all directly within the from clause now for a Match Recognize statement. So it's a subtle change here. The from clause becomes the input into your Match Recognize. So the where clause goes within the from part in this case. And then we can add Match Recognize, and we're ready to start laying out how we're going to process this data. Now the first part is we need to divide up. Remember what I said originally when I said there are 4 elements to this. The first part is we need to break down the data set and make the pattern visible. So we'll need to partition this by user ID and by time. So if I step back a second to here, in this case, we would expect to have, if this was a much bigger data set, we'd have multiple user IDs. Now, obviously, we're only looking for patterns within each user. So if I had Mary underneath here, I'd be looking for suspicious transfers within Mary's account, separate from looking for suspicious transfers within John's account. So therefore, I'm going to need to partition by the user ID. Then I need to order those transfers because I'm looking for data within 30 days and within 10 days, which implies that I need to have some sort of ordering here. So I'll need to order by time. So that, if you like, gives us our first two elements that need to go into our match recognize: partition by and order by. So they make the pattern visible to match recognize. Step two, we need to work out, okay, what is it that we are going to pull out from this? And what I need to know is, okay, what is the elements of the first transfer? What is the elements of the last transfer? And the first transfer is my small one. The last element is my large transfer, and I'm looking for the time components of that. Which days did those occur on, and the amount of the last transfer. And if you notice here, there's some new syntax here. We've got words like first and last. There's some new keywords that we've added here that allow you, as you're processing, to, if you like, pull out from that process, that pattern matching process, elements that we've matched. First and last being fairly self-explanatory, the first row that I find and the last row that I find within that match. And you'll also notice here I've got some symbols X and Y here. We'll come to that in a minute. Okay, so that's what I want to get out. The next thing I need to determine is what type of information do I want back when I discover a pattern. Do I want as much information as possible, or do I want a summary? And in this case, what I've said is I'm going to go for one row per match. So if I get a match, it's going to return one row. This is the match, and it's going to give me the first month or the first time ID, the last time ID, and the amount for each match that I find. Now, when you do this, depending on the requirements being passed back into your calling application, you may have other requirements. You might want to see all of the rows that are matched, the sequence of them coming back. So, in this case, we're going to see 4 rows. If I said all rows per match, I'd see 4 rows coming back. For the first element that's matched, then I'd see the second small transfer, the third small transfer, and then the large transfer. And maybe I would need all of that information, which rows were actually matched. Typically, all rows per match, and also return the whole data set to me, including unmatched rows. They're quite useful if you're debugging. It's always good to make sure not just that it returns, so you get some data back when you run this, but you get the data back that you're expecting, and that you match the rows that you're expecting to match, and you don't match the rows you're not expecting to match. So all rows per match with unmatched rows are quite useful for debugging purposes. And I go into a lot more detail in that PDF that I've linked to. There's also some, okay, I found a match. Where do I start looking for the next pattern, the next match in my pattern? And there's various ways that you can control whereabouts in the data set you start searching again for the next match. And it could be that the type of pattern that you are searching for requires you to look for overlapping patterns. There are scenarios where that can occur. And I'm not going to go into too much detail here, just to say that that is possible, and it's all sort of explained in this much deeper PDF that I've provided you with a link to. Okay, next part. Let's describe the actual pattern. So remember I said that we had first x.time ID. What does x mean? X has a specific meaning within this pattern. And the first thing we do is we say we're going to have a pattern, and this is how we're going to lay out the pattern. And the pattern is going to have this object called x, And in this case, if you remember the business requirements, I'm going to look for X, whatever X is. We'll come back to that in a minute. I want to find that 3 times. So this is matching back to, okay, it's going to be a small transfer, and I'm looking for at least 3 of them. And then we have the other requirements after that. So you can see X is going to be something to do with small transfers, and I'm going to look for 3 of them. Now, if you're used to regular expressions, if you're used to other pattern matching syntaxes, languages, you'll recognize that how we determine how often we are looking for a pattern is usually controlled by regular expressions. And there are various different types of regular expressions. The one I'm using here is I'm looking for n or more matches. So in this case, I'm looking for 3 or more small transfers, but there must be at least 3. And there are various other operators that you can use. The next step is looking for this big transfer. So I'm going to search for one element, one instance of Y. Now notice I've just put Y here. I could have used Y curly bracket 1, close curly bracket, to say I'm looking for precisely 1, but just putting the pattern variable itself, Y, with no other quantifiers, automatically indicates that I'm just looking for 1. Okay, so that's what I'm looking for. 3 instances of X, 1 instance of Y. But what is X and Y? So the next part, the next step in this is the define keyword, where we lay out what exactly X and Y is going to be. So X is going to be where the amount is less than 2,000. So as I'm going through my rows, I'm going to go down the amount column and look for instances where X is less than 2,000. Where I find I can keep on going through this, it's less than 2,000, and don't forget they have to be within a 30-day window. So I'm looking for transfers out of John's account that are less than 2,000, and what I want to then do is look at, here's the first match, so remember that, and then take the last, or the last match that I find, check the difference between the timestamps and make sure it's less than 30. So I'm going to keep on matching 2,000, 2,000, 2,000, and 2,000 until I don't find, till I've got at least 3, and then check that the last time ID minus the first time ID is less than 30. So I'm stepping back through my rows, having matched patterns to check the time IDs. So that's my first business rule. My second business rule belongs to Y, and it says, having found those 3, and the fact that those 3 transfers occur within a 30-day window, I now need to check that the amount that is transferred, the next one, is more than $1 million. And that the time for that transfer of that large amount is the time difference between that large amount and the last small transfer, which we get by using last x.time ID, is less than 10. So there's only a 10-day window between the last small transfer and this transfer. Now, the next bit is we need to match recognize is going to return data, in this case, the columns that I've outlined here in my measure, to my select clause. So they are now going to be the columns that I can select from, not the select in here. So normally from the from clause, you would pull out the columns from that table. Here, you're using the select from, the from part as the input to match recognize, and match recognize is returning you a new set of columns that you can then select from. So I want the user ID, the time for the first transaction, small transaction, the time for the last large transaction, and the amount of that large transaction. So that becomes my select statement. Now you could, if you wanted to, do select star here. So I could do select star from, so my select statement, match recognize, and all of that code, and it would work. You would get exactly the same answer. It's probably not the best idea to use select star for reasons that I'm not going to go into here, but just be aware select star should probably be avoided because you can change the information that's going to come back as you modify this code. So it may be a little bit of a surprise to see certain things appearing and disappearing as you change the structure of this match recognize statement. I'm going to say it's all in the book as to why this happens and how it happens, but it's good to know that don't use select star. Always lay out precisely the columns that you want. If nothing else, it just lets the person who's going to come along afterwards, as we'll see when we get to the next part, these are the columns that you were expecting to get back. So if another developer comes along and has to amend your code to do something different, at least they know what you were expecting back. Okay, so we could, let's go to here. So we've got our transactions in here. We can, this is the code for accessing our JSON table. Now here you'll see I've got deposits, I've got withdrawals, so I've got various types of different transactions. The only thing I'm really interested in is, hopefully this doesn't time out on me. Got a horrible suspicion it may have done. I gotta try that again. There we go. Sometimes you get a timeout. So those I've taken my list of full transactions, and what I've now done is just pull out the event IDs. So you can see here, you can select on JSON documents and pull out and process data in exactly the same way. So here I've taken a key value store data set and converted it to row column format, and I'm able to do normal SQL operations on it. So that's going to, in effect, be my input into my match recognize statement. So let's just run that and see what comes back. Oh, let's try that again. I knew this would happen. Sometimes this happens with SQL Live. It's not going to clear. I wonder if I do clear and then do insert this. I don't think it likes me actually logging out or not using this. Oh dear. I wonder if it's always the danger of doing things that, okay, so it looks as if Live SQL, we may actually be doing some work on it, which is not surprising given the time. Okay, so let's say we've got our data set, and we've pulled out the data set that we want to look at. We found our fraud, we've given that to our business users. The first thing that's going to come back is, okay, that was fine, but we need to make some subtle changes to our definitions here. So we now want to do some additional processing here. What we now want to do is check for transfers of different accounts, that the total sum of the small transfers must be less than 20k. Okay, so what our developer has done is they've updated the structure of the JSON file. We've put some new information in there, such as the transfer ID. So I can then see the account that the information's moving to. So they've gone in and done their thing, pushed out their new key value log file, and voila, we're ready to go. So we've changed the model that we're looking at now. So the question now becomes, okay, my JSON file has completely changed. We've got new columns in here. We've got new key values that I need to process. If I put that in place now, can I still run my original match recognize statement that has no idea about these new business requirements? Could that still continue to process on this new JSON file? And the answer is yes, quite surprisingly. We can still we can bring in the new JSON store, which contains the transfer ID key value pair. And I can put my new relational table structure into place, and it will still continue to run the original match recognize statement. So my application, if I've changed the log file, my application that is taking data from my original match recognize statement will actually continue to run. Now, that may not sound surprising to a lot of people, but for a lot of developers, etc., that are used to using these sort of key value store arrangements, that's quite an unusual thing for the code to still work even though the data model has completely changed. Okay, so what we need to do is look for these instances where we've got these transfers and the account names are different. So in other words, what I'm doing here is transferring money out. I've discovered somehow that this is probably what the bank is doing, and what I'd like that they're somehow monitoring this, and so I'm going to move money out to different people so it looks as if I'm paying different people. So hopefully this then doesn't raise any flags within the bank to say, oh, something fishy is going on here. But of course it is. All we've done is, as a smart person, is tried to fool the system. And this is what the business units have looked at and said, okay, there's actually something different here that we need to capture, and we need to find all these different transfers now. So the good news is, if we wanted to do that, if we wanted to make that change, we don't have to start from all over again. We don't throw away all the code that we had before. We can still use exactly the same code. All we've got to do is add some new definitions in here to our define statement. This is all we need to tweak, is the define statement to look for these new business requirements. So what we need to do is check the transfer account. So we now need to see, okay, who are we transferring to, and to make sure that the names are different. So all I've got to do is say, okay, the transfer ID, make sure that it's different, i.e. it's not equal to the previous transfer ID. So here I'm going to look at the current row where I've matched the amount is less than $2,000. And I'm going to make sure that the transfer ID that I am for the row that I'm currently on is not the same as the previous row. So I'm able to step backwards. I can also use next as well to look forward. So previous and next allow me to look forwards and backwards through the data set and then compare values with the current row. So you've got also things like first and last. So I could look at, say, the first transfer ID is different to the last or the current transfer ID. And then, of course, we are still making sure that the transfer amount is less than 2,000 and the first and last time ID has a time span of less than 30 days. The final statement is that if we looked at all of these small transactions, that the sum of all the small transactions, i.e. the sum of X amount, so I've got a complete match, I've found a series of transactions, small transactions, at least 3, so I've got at least 3, but there may be more than 3, where we're moving less than £2,000 to different accounts within a 30-day period, and the large account transfer is more than £1 million within 10 days of the last small transfer. And if I look at the combination of all of those small transfers, which must be at least 3 but maybe more, the sum of all of those matches is less than 20,000. So I can do aggregations here within a window as I match things. You know, I can look at the average, I can look at the min, I can look at the max, I can look at the total amount using sum. You can use aggregation operations here to check within a window, within a match, within a partition for a given order by, that I can do aggregation operations to get various other pieces of information out about the pattern that has been discovered. Okay, let's see if we can, let me come out of this. I'm going to see if Live SQL will come back. So let me close Safari and try and go back in. So I'm determined to get into Live SQL. Yay! I think it might be back up. I think the problem was actually the fact that I did not continue to keep using it. So let's go My Tutorials, Fraud Demo. Okay, let's run it. Okay, so now we'll have to quickly, this is the advantage of Live SQL, we can quickly insert that and run it. Table created, insert our data, run. Okay, I'm just going to insert this, which is our original, and there we go. So if you remember our original statement, our original business requirement is, okay, find the transfers less than 2,000, last time ID minus first time ID is 30, less than 30 days for the small amounts, and then my large transfer greater than £1 million within 10 days of the last, and return the user ID, John, the date of the first transaction, which is the 2nd of January, date of the last transaction, which is 27th of January, and the large amount is £1 million. So in here, you'll see, I'll go into a lot more detail about how you can do processing, how you can use match recognize. So we can run the same statement and we can put some additional information in here that will help you do debugging. Okay, so how about if we completely change our business transactions? Okay, so what I've now done is I've created the user ID, and for each transfer I've now added a transfer ID, a key value pair, transfer ID John. So my table now looks different. Now if we go back up here, remember I said, okay, would our original statement, even though we've changed the business requirements and developers have updated the JSON file, will this actually run? And the original match recognize, even though this the actual input for this, our JSON transactions, the actual data model of key value pairs has changed because we've added this transfer ID. But because we're using SQL to access this, we can actually get this to actually run and still return the same result. So we know it's still working correctly, even though the data model has changed, because we now want to be able to compare who we're transferring to, which accounts is this information going to. So if we look at this lot now, you'll see, okay, my data model's changed. So I've now got this transfer ID. Wherever I've got a transfer, I've got a new key value pair that gives me the transfer name. And where I'm doing a deposit, obviously there is no key value pair element in there, so that column is just null. So here we go. Does our query still run? Our original query, yes, it does. So now we can insert a new query. So again, I want to find the transfer information. So I want to now pick up and use this key value pair, this transfer ID, and I want to look at the total value of my small transfers. So that's my new set of requirements, and we can now run that, and we can see again the basic input information doesn't change. We still get the same information back. So we're still looking at essentially the same records being pulled out and highlighted, but we've got more information to process to make sure that those transactions that we identify are in actual fact fraudulent. Now we could provide a lot more information back to our business users. So I've put in a lot more information here, and if we run this one, you'll see, okay, so what I've done here is say, here's my user ID, here's the first transaction, and the amount of the first transfer was 1,000 and it went to Bob. The amount of the second transfer was 1,500 and it went to Alan, and the third transfer was 1,200 and it went to Tim. The big transfer happened on the 27th of January, and it was for that amount, and it went to Tim. So you can see here what we've done is I've used first and last here to get first time ID here and the amount. And then what I've done is get the transfer amount and the transfer ID. So here's my transfer ID, here's my transfer amount, and you'll notice here I've got first transfer amount, and then I put a number. So I can say I want the first, but I want you to move forward one row from first and pull out the second row. So first column, comma 1 means get me the second row. So that gets me my second transfer, and so on. So you can pull out different pieces of data by pulling out and sort of manipulating where we look for pieces of information and then code it up accordingly. So if I did first transfer XID 2, that would get me the third value that I'm looking for. So it would get me the third transfer of the small amounts, and so on. Again, I've got more details on this syntax. It's very useful to be able to move around your data set. Think about this in terms of being able to look within a partition, within the order that you've got. Within that partition, you can move anywhere to find the values that you want. You can go to the first row, you can go to the last row, you can go to specific rows. So that whole partition is available for you to interrogate and manipulate and pull back information from. So it's very different from, it's sort of similar to windowing using the analytic window functions, but it's also not, it gives you more functionality in that you can also move around within that window and start pulling out pieces of information that are of interest to you. So it's very, very powerful, this. And it has a lot of applications, which is why in the PDF, the first, well, also in the iBook, the first thing we do is get into some use cases that will give you some idea as to how you can use these new features, this new feature. So there's some use cases laid out in there. There's all the code related to those use cases, just to not only give you an introduction to Match Recognize, but also explain, okay, this is how you could meet this business requirement. Now, you could do quite a lot of these, including this particular requirement, using window functions and the with clause to create multi-step SQL statements. Of course, the problem with multi-step SQL statements is trying to do this whole thing of, can I change the business rules? And of course, within a multi-step with statement, you know, you've then got to, if you're the person who's then got to come in and change the business rule, if there's lots and lots of SQL code to go through, it gets quite challenging to work out where to make the change. Here you can see it's very, very easy. You know, the only thing I've had to do is add 2 lines to change those business requirements, put in the transfer information, check that, and check the total amount. So it's very, very easy now to start with a basic set of business rules and then update those business rules as we go along. That's the first, if you like, advantage. It's bringing a new level of simplicity to your SQL code, but it's also making it a lot more powerful. So you can do very, very complex processing within a partition, but the code to do that is very, very simple compared to using a with statement and analytic window functions and things like that. The other key advantage is, because you're using SQL rather than a non-SQL language or a SQL-like language outside of the database, is that you can now use all of the other analytics that are inside the database. And what we did for Open World a couple of years ago, and it's linked down the bottom here, when you get the slides you'll be able to see this, we combined pattern matching with geocoding and spatial analytics to create a demo whereby we could analyze fraud in real time based on locations. So I might, for example, you can see the red elements here, my first transaction that comes through in my real-time feed might be me going into the Apple store in Miami and, let's say, buying a new keyboard for my Mac. A couple of minutes later, right over here, it might be me going into a completely different store, let's say going into Target and buying all sorts of clothes. So the question would be, for the fraud system, can I get from there to there in 2 minutes? So we could use spatial analytics to look at the distance from A to B, convert that to a, if you like, a miles per hour, and see whether it's technically feasible to have moved from A to B within that time frame of the difference between the first transaction and the second transaction occurring. And if that's not possible or unlikely, and you can define the business rules for unlikely, then you could flag that up as a fraudulent transaction. straight away in real time. So that's a demo that we built for Open World that Andy Mendelsohn used. Another demo that we built, we did a similar process of comparing. Okay, let's use Java, which is possibly not often used for pattern matching, but is increasingly being used. A lot of people will use Java to do, write the code within a Java object and use that to do the pattern matching, particularly for real-time processing. So we had again a simple business case, and we put that functionality, mapped it into Java, wrote all the code to do that, and we came up with, and this was a particularly good Java coder. I won't give you their name, but they know what they're doing with Java. They are pretty good. And we looked at writing that in Java and effectively creating a MapReduce job to run that. And it came up with nearly 700 lines of Java code to do what was a very simple pattern matching requirement, compared to, I think it was something like 20 odd lines of code in SQL Pattern Matching. So that's a huge difference in the amount of code. You can imagine doing a fraud detection in Java, and then the business come back saying, yeah, that's great, but could we actually do something a little more sophisticated and change this and check that? Now you've got to go through 700 lines of code compared to the small sort of 20 odd lines of SQL Pattern Matching. But if you look at the execution time, so I want to do this in real time, it becomes possible to do real-time processing using SQL Pattern Matching. But if you've got to wait over a minute for that code to execute in Java, that's kind of a block to try to do real-time processing. So you're getting the power of SQL processing, and as we move forward with database features, you've probably already seen in 12c release 2, there's all sorts of new in-memory capabilities. Because you're using SQL and you're using pattern matching, we can automatically inherit all of those performance optimizations. There's nothing you need to change in your code to make use of, say, in-memory processing. There's a lot of in-memory capabilities that we added in 12c release 2 to optimize SQL processing. And if it's written as a SQL program with match recognize, your pattern matching automatically inherits all of those capabilities. So in summary, hopefully what I've shown you is how to put together a match recognize statement, how to define the search criteria using pattern matching variables. If you flip over to the live SQL functionality, you'll see I've put some additional information in there that allow you to debug your pattern matching process. Actually check to see whether it's working. And you will need to do that. Don't rely on the fact that just because you get rows back that, oh, okay, it's working. You will need to make sure that it is returning the rows that you think it's returning. And we give you some built-in debugging tools to help you do that. And they're in the live SQL examples. We've shown you how to use the built-in measures, the standard aggregation capabilities, the new keywords like first, last, previous. There's also next. There's some other keywords that you can use. And in this last section where we've looked at, okay, what is the value of using SQL? Okay, obviously it eliminates a lot of code. It makes it a lot simpler. Match recognize simplifies the SQL code again, because obviously we can do a lot more powerful things in a lot less code, say, compared to using the window functions. But the real power of taking this from other non-SQL based or SQL-like languages is the fact that you've now opened your processing up to all of the SQL analytics that are inside the database. So what I'd love you to do at the end of this is to, if you've got access to database 12c, is to go and use pattern matching, find examples, business cases in your arena, and use match recognize. It's very, very powerful. There's lots and lots of different things that you can do with it. And I've got on the OTN homepage, in my blog, on Twitter, lots and lots of examples of types of things that you can do with pattern matching. And we've got white papers, there's Oracle by example. As I say, there's a whole suite of things on, I go back to Live SQL, go back to my tutorials. There's a whole series of tutorials that I've put on here for doing, if you like, introductions to match recognize that are linked to that ebook that I showed you, looking at partition by and order by. Why would you use partition and order by? They're not mandatory, but there's some examples here of what happens if you don't use partition by and order by. You can think that you've got the right result when in actual fact you haven't. And then we have the fraud demo here, some use cases. If you've used ListAg and you've run up against the typical ListAg problem of you have too many string values, well, we fixed that. We have actually fixed that. That's a whole other topic on ListAg, on what we've done in 12c release 2, but we fixed that. But if you haven't got access to 12c specifically release 2, you can use match recognize to truncate and manage those ListAg overflows. And then there's a whole series of other ones here. So I'm going to let you play with those. There's always new stuff that I'm putting into my blog. So with that, we'll switch over to questions. I'll see if there's any questions. I haven't seen any pings from my moderator to say we've got questions. So let me quickly flip over. Okay, looks like no questions. I am pleased with that. I'm hoping that means everything's good. As I say, if you start to use it, if you're using it and you've got questions, by all means just email me, ping me via Twitter, ping me via my blog. I am more than happy to answer questions. I'm also interested in use cases that you've got. By all means, send me additional use cases. If you've got enhancements, we'd love pattern matching to be able to do A, B, or C, or X, Y, and Z. Send us your enhancement requests. We're always looking to extend pattern matching, to add new functionality to it, and we continue to enhance as we go along. So always keen to understand how you're using it and what you'd like it to do. So with that, I will say thank you very much, and thank you for listening and joining. Have a great day.